Alright, so in this video we're going to be working on the point of intersection of linear graphs. So we are going to be modeling two linear equations on the same graph, and we're going to find out what it means when they intersect. And so to help us see that, we're going to be using this story problem about t-shirts. Alright, so we have t-shirts that are being charged $4 each, and then there's a setup fee for $160. And then we would sell our shirts for $8 each. So the company is going to charge us $4 for each t-shirt and a $160 setup fee, and we can sell them for $8 each. So to help us figure this out, we're going to write some equations. So here's our first equation. We're going to write an equation to represent the cost to the organization, how much we're going to spend to get the shirts. So we're going to do y equals 160, because that's my setup fee. It only happens one time, so there's no variable with it. And I'm going to add it to 4x, because we're getting charged $4 for every shirt. Then this is going to be our income equation, our second equation. This equation is going to represent how much money we get. So y is the total money we get, and it's going to be $8 times x. And x represents the number of shirts we sell. Okay. On the left side, 160 is our setup fee, and then x is the number of shirts we order. They cost $4 each per shirt, and here we're selling them for $8 each. Okay, so we have our two equations. We're going to be using a table down here to help us organize our information. So let's put these equations in here. So my expression for the number of long sleeve shirts is going to be x. And then the cost in dollars, that expression is this one here. So I'm going to put that in here, 160 plus 4x. My income equation is this one, so I'm going to put that in here, 8x. And then my profit is the amount of money I have after I take my income and I subtract the cost. So here's my income, and then I'm going to subtract the cost, which is 160 plus 4x. Now I can use this table to help us figure out the profit we can make from selling different amounts of shirts. So when there are 0 shirts being ordered, I still have to pay 160 for my setup fee. So my cost is 160, but my income is going to be $0 because I'm not making anything. When I plug it into my profit equation, I have 0 minus 160. So right now my profit is a negative 160. Okay. Now we're going to be plugging it in for different amounts of t-shirt quantity. So if I'm ordering 10 shirts, what's that cost going to be? I'm going to use this equation. If I order 10 shirts and I sell them at this equation, that amount will go here. And then what's my profit for selling 10 shirts? That'll go here. And to help me do that, I'm going to be using a calculator now that I have my equations set up. Okay, so here we go. My first one, 10 shirts, 160. Well, what is that? 160 plus 4, and instead of x, it's 10 shirts. So what's that giving me? 200. And my income for that is going to be 8 times x, so 8 times 10. That's 80. And then my profit is going to be my income, which was 80, minus my cost. So 80 minus 200. Negative 120. So right now I'm not making any money. I'm actually $120 in the hole. So let's go to the next row. 20 long sleeve shirts. So 160 plus 4, this time with 20 shirts. That's 240. And then my income, 8 times x, which is 20 this time. So 160. To find my profit, I'm going to subtract my cost from my income. So we have 160 minus 240. Now we're only negative 80 profit. Okay, so let's keep going. 160 plus 4, and this time we have 35 shirts. And my income is going to be 8 times 35. And then my profit is going to be 280 minus the 300. So I have $300 cost, $280 in income, and I have a negative $20 in profit. All right, let's do 50 shirts. 160 plus 4 times 50. Then we have 8 times 50 for my income. And then my profit is going to be 400 minus my cost, which was 360. Oh, and now we have a profit. So my cost was 360, my income is 400, and my profit is $40. And let's do one more for 100 shirts. 160 plus 4 times 100. And my income is going to be 8 times 100, it's 800. And then my profit is going to be my income minus my cost, which is 240. Okay, so now we have all this information. We can use a table to show the cost, income, and profit for the different number of shirts sold. So we can take our equations here, and we can create a graph to represent this as well. So I have a graph that I made. Where is it? Oh, it's right down here. So I have a graph that I made using Desmos, and I plugged in my two equations. So my first equation, 160 plus, I'll label the line. This is y equals 160 plus 4x. And my other line, the green one, was my income equation, y equals 8x. That's kind of hard to see. But we can use this graph to help us answer a bunch of questions about this problem. So we can determine the number of long sleeve t-shirts when the cost is greater than the income. So my cost is this line, and my income is the green line. So this represents the shirts on the bottom, long sleeve shirts. So when I have 5 shirts, my income is only going to be $40, but my cost for 5 shirts is like $180. So my cost is way higher than my income here. So there's a huge difference there. There's a huge difference there. From 0 shirts all the way here until this point, my cost is greater than my income. So this point right here is, let's see, what is that? 40 shirts and 320. So all the way up to 40 shirts, my cost is going to be more than my income. But after that, after this point, from 40 shirts on, my income line is higher than my cost. So after 40 shirts, I start making more money. I start making a profit. At this point here, at this intersection point though, this is called the break-even point. And at this point, my cost is the same as my income. At that point right there, at 40 shirts and $320. So when I sell 40 shirts, it costs $320, and I make $320 back. Okay, so this is a walkthrough of what the point of intersection means. The point of intersection is when my two linear equations cross each other. When one line represents the cost and one line represents the income, the intersection is called the break-even point. Okay, well, thanks for watching.